By now, everyone knows that Z-Image Turbo is fast, but as you crank up the resolution, generation times do get longer, and low VRAM machines start going out of memory. To solve this, pairing it with one of the best upscalers in SeedVR2 can help keep generation times quick while giving the flexibility to upscale the images you want. You can even get up to 4K using SeedVR2 on 8 gigs of VRAM, and I'll show you how. Let's get into it. Okay, there's a couple of things you need to do to set it up before you start using SeedVR2. The first is to get the SeedVR2 custom node, and you can get that from the manager, custom nodes manager, then searching for SeedVR2. And the one you want is the SeedVR2 video upscaler, so just install that one in the nightly version. Once it's finished installing and you've restarted Comfyui, you should be able to find them in your nodes list. So if you double click and then search for SeedVR2, you should be able to see the nodes that are part of the video upscaler one. You only need 3 of the nodes to start doing the upload. The first is the load dit model, then there's the load VAE model, and then the last is the video upscaler itself. I'll go into the settings and how it all hooks up, but first you also need to download a couple files. You can let the load dit model download on the first try, but if you download it yourself, you just have more control over which files you need. Before you start downloading anything, you need to create the SeedVR2 folder inside the Comfyui models directory, and then inside there, you'll place the different models and the VAE. So for people with 8 gigs of VRAM, SeedVR2 is very hard to run. Some of you may have tried to run just a regular 3 billion parameter model before, and even that used to destroy your computer if you had low VRAM. But with the more recent Comfyui node and the GGUFs that are created, you're able to run at least an image generation up to around 4K. So for me with 8 gigs of VRAM, I've been using the 7 billion Sharp Q4 GGUF. If you run into issues with that, I would drop it down to a Q3 as well. And then obviously if you have a bit more VRAM, you can try the Q5 or Q6. From this side, I would grab the Sharp Q4 and also the regular Q4 just in case. And I'll show you some comparisons between the two of them. For the 3 billion, if you really want to, you can try the Q8, but I've generally stuck with the 7 billion upscalers. The other file you need comes directly from the SeedVR2 repository, and that's the EMA VAE. So again, once you've downloaded those files, just make sure you put them inside the SeedVR2 folder inside the models directory. Once all your models are complete, if you're still in Comfyui, just make sure you hit the R button to do a refresh on the folders. And from here, you should be able to see all the different models that you've downloaded inside that folder. And now I'll go through all the settings, especially the ones that will help you run on 8 gigs of VRAM. So the first thing you need to do is just pick your model. If I'm upscaling from a low resolution image, I would generally use the Sharp model to produce an initial sharper image. Then for the device, you leave it on your GPU. The blocks to swap setting is important for low VRAM, and you generally want to max this out, which is 36 blocks. This means it'll start offloading and doing blocks at a time. Once it's finished one block, it'll put it off the VRAM and onto your system memory, which helps keeps the VRAM usage lower. You can leave swap IO components as false, offload device to CPU if you can, cache model as false, and then attention mode you can leave as SDPA. Then the second node, it's also important to get this one set up correctly. For the VAE, you choose the VAE that you downloaded. Device, again, make sure it's on your GPU. As you're upscaling to bigger resolutions, you need to make sure that the encode tile is true. So now you're doing it tiles in smaller tiles at a time instead of one giant image. So make sure this is true, then leave the tile size and the tile overlap as default. So the defaults are 1024 and 128. And then you also want to do the same for the decode. So when you encode the image, it does it this way in tiles. And then when you decode the final image after upscaling, it also does it in tiles. In this one, you set to true, and then the same thing, 1024, 128. Tile debug you can leave as false unless you're having issues and you want to see what's going on. And then offload device you also set to CPU. Then cache model also false. So these are the most optimal ways to set it up for low VRAM users. And then for both of these, they plug right into the video upscaler. So the DIT goes into the DIT, and then the VAE goes into VAE. And then obviously your source image goes into the image model. So inside the upscaler, there's only a couple options. You still have your seed, you can leave it as randomized, and then your resolution that you want to upscale to. So going from 1024 to 2K is pretty easy, and that's pretty quick. Just make sure you set your resolution. This is on the short side, I believe. And then your max resolution just handles your long edge. The max resolution is more important if you have a non-square image and you want to make sure your long side is within the bounds. So if you're doing a 16:9 image, then you would want to set max resolution as 2048 or 4096 for a 4K like cinematic type shot. Then the next setting you need to make sure is the batch size is 1, since you're only doing one image. And then the others you can leave as default. Color correct, which will color correct after it's done the upscale. Leave that as lab. Temporal overlap 0, prepen frame 0, input noise scale and latent noise scale, you can leave those as 0. Offload device to CPU to keep things off the VRAM. And then enable debug as true is quite helpful if you're running into memory issues to see where exactly it is that you're running into it. And then once you do that, you can just run. So for me, an upscale takes around 30 something seconds. So you can see a history of it here. Going from 1024 to 2048 is 32 seconds. Going from 2048 to 3072 is about 64 seconds. So it'll run, but it's a little bit slower. So 60 something seconds for 30. And then here's another few at the 2K. So 30 seconds, 32 seconds, 30 something seconds, etc. So it's generally around 30 seconds and then about 60 something seconds to go to 3K. But going to 4K for a square image like this, I find that I run out of memory on 8 gigs of VRAM. No matter what settings I do here, there's nothing I can do that kind of help it. But for example, if it's a 16:9 image and I go from 1280 by 720 up to 4096 by 2304, that will work, but it takes a little bit longer than a minute. So with that out of the way, let's take a look at some of the comparisons and seeing what SeedVR2 can do. So for this first image, is going from 1K to 2K, and here is the before. So the before, you can tell it's already a little bit blurry if I start zooming in a lot. And then the upscaler will definitely clean it up. And using the sharp one, you can tell there's a noticeable difference just on the fine details everywhere on her face, her hair, etc., and her skin. From her spiked bracelet here, you definitely get a lot more detail coming out after the upscale. SeedVR2 is also really good at keeping depth of field, so it knows which parts are supposed to be blurry and it doesn't try and upscale those. But the ones like the gold trim here is still blurry, which is supposed to be. But the ones up in the foreground here, like her cloth up by her shoulder, this all gets a lot more detail. Here's another example of a 1K to 2K. If we zoom in again, it's quite blurry to start on a 1K image, and SeedVR2 will upscale it quite well. And the good thing about SeedVR2 is it'll keep most of the structure and details the same while just giving you an upscaled image. So same thing here, it starts adding more details in the leather strap. Down here as well. And the gauntlet also gets more details and just clearer. And then here's another example. We can see like the eyebrows definitely gets a lot more sharper. There's just more detail overall. One of the other comparisons I also wanted to show was going from 1K upwards. Like, should you do it from 1K to 2K and then 2K to 4K, or should you go 1K all the way up to 4K directly? So here's a comparison doing two of those. The one I'm showing right now is 1K straight to 4K. And then as I flip over, you'll see the one that goes from 1 to 2 and then 2 to 4. And there is a big difference between the two of them. So if you go 1 to 4, there's not as much information that the upscaler is working with. So a lot of the fine details like the zippers, the buttons, the text on her shirt here, it's all kind of just jumbled because it's going from a low resolution all the way to 4K. But if you do an in-between from 1 to 2, it gets more detail added, and then you go from 2 to 4, and that'll just keep cleaning up the details even more. So here, if we zoom in even more, you'll see that the 2K to 4K is just a lot cleaner, and there's more details in the buttons, more details in the zipper. Everything's just a little bit sharper. So even her face is a little bit sharper in the 2-stage process than just the 1-stage. This one is a little bit over sharpened. So if you think that this image is a little bit too much detail or a little bit too sharpened, That's why I said you can also download both the Sharp version and the normal version. And here's a comparison between the 7 billion Sharp and then just the normal. So sometimes it's better to go 1 to 2K on Sharp and then 2 to 3K or 2 to 4K on just the normal, so you're not over processing it. In this image, the one here that's before, that's the Sharp, and then the one that as I flip across is the normal. So you'll see things like on this coin here, it's very contrasty, and there's a lot of micro details in the coin on the Sharp. And then if I use the normal one, it's slight, but you can see it's just slightly less contrasty and less processed. Um, Same as her face, right? Her face just has a lot of minor details on the Sharp version, but the normal one smooths it out a little bit while still being upscaled. So it's subtle, but it does make a difference. So you can mix between the two of them depending on which look you're going for. Hopefully this video helps you out. It lets you set up SeedVR2 on lower VRAM machines. I know I had a lot of problems with it before I started testing with it, so maybe this will help one of you guys out as well. If you found it useful, give it a like, subscribe if you can, and I'll catch you in the next one.